Good morning children, today we are going to see Paschen back effect. So before this we have seen Zeeman effect, normal Zeeman effect, anomalous Zeeman effect. Related to that we have seen the splitting up of sodium D lines. And today we are going to see Paschen back effect. After that Stark effect, the syllabus of this unit will get completed. So you must remember here everything. That the splitting up of spectral lines is due to the application of magnetic field. I have told you Zeeman effect, normal Zeeman effect, anomalous Zeeman effect. If a magnetic field is applied on a spectral line, if it splits into two or more lines, it is called Zeeman effect. If it splits into more than three lines, then it is known as normal Zeeman effect. In a weak magnetic field, if the spectral line splits into more than three, then it is known as anomalous Zeeman effect. So based on that, we have seen Debye's explanation, Lorentz theory, splitting up of D lines. And now we are going to see what is meant by Paschen back effect. So this is the name of the two scientists, Paschen and Back. Paschen and Back found that the anomalous Zeeman effect of a given spectral line in a weak magnetic field approximates the normal Zeeman triplet. So, when Paschen and Back applied a magnetic field on a spectral line, they found that the Paschen-Back effect was nearly equal, that means approximately equal to anomalous Zeeman effect. That means what? Anomalous Zeeman effect. If a weak magnetic field is applied on a spectral line, it splits into more than three lines. That is known as anomalous Zeeman effect. So same effect has taken place here. Now we are going to consider two vectors, L vector, J vector. And you know that the sum of this L vector and S vector is equal to J vector. So we can write this there, J vector equal to L vector plus S vector. L vector is orbital quantum number. S is orbital spin quantum number. Orbital quantum number, orbital spin quantum number. So due to the spin, we get a quantum number that is ms. Due to L orbital quantum, we get orbital quantum number m of L. We know that in the coupling schemes, I told you that J equal to L plus S. Therefore, J vector equal to L vector plus S vector. So when you are applying a magnetic field on a spectral line, it gets split up into three lines, and that is equal to anomalous Zeeman effect that was proved by Paschen Back. And as the field strength increases progressively, how it is happening means they are increasing the weak magnetic field strength. When they are increasing the strength of the weak magnetic field, you can see that the spectral line is getting split up into three, that is known as triplet. Singlet means one line, doublet means two line, triplet means three line, quadruplet means four lines. So this may occur due to collisions or disappearance of certain lines. So when such splitting up is taking place, there may be either collisions or disappearance. Collisions means one line will coincide with the other, or one or two lines may disappear. Suppose if there are five lines, one or two lines may not have very good strength. So they will either what? Combine with each other, or they will disappear to the variation of the weak magnetic field. So that is what known as collisions or disappearance. Collisions means either they will collide with one another or they will disappear of certain lines. This phenomenon is called Paschen back effect. So when a spectral line is applied, when a magnetic field is applied on a spectral line, splitting is taking place in a weak magnetic field, that is nearly equal to anomalous Zeeman effect. And if the strength of the weak magnetic field is increased step by step, at a certain stage there may be either collisions or disappearance of lines, and this phenomenon is known as Paschen back effect. So if they ask in 2 marks, you write only these 3 points enough. If they ask in 5 marks, they will ask what is Paschen back effect and give its explanation. So you have to draw the diagram, write Paschen back effect, and now I am going to tell you the explanation of Paschen back effect. So now I am going to consider strong magnetic field in which I am taking two orbitals L and S. In a strong magnetic field, L and S break down and J loses its significance. We know that J vector equal to L vector plus S vector. That is the quantum number, spin quantum number, orbital quantam number. That is equal to total orbital quantum. J is your total orbital quantum number. Suppose if L and S break down, then J will lose its significance. Significance means it will lose its importance. Therefore, we can't write J is equal to L plus S. Therefore, the energy change due to the presence of the field may be due to about L and B and S about B. L about B and S about B. L about B and S about. So this is the strength of the magnetic field I am applying. So one vector precising with it is L. One vector precising with it L, S. Now therefore we can see what will be the change in energy. We can see what will be the change in energy. The change in energy is expressed in terms of the strength of the magnetic field. Therefore, the change in energy, delta E is equal to delta E due to RL and delta E due to spin S. Delta E due to L and delta E due to S. That can be written as delta E is equal to EH by 4 pi m. H is Planck's constant, E is the charge of the electron and m is the mass of the electron. EH by 4 into strength of the magnetic field. Last class as I told you that EH by 4 pi m B into G m of J. G is Landé's G factor. So this will be into m of L plus 2 times m of S. You may have a doubt, why sir you are writing 2 times m of S? Spin is of 2 types, clockwise spin, anti-clockwise spin. So whenever I am teaching in the video, you take your notes, keep it side by side, see the notes and listen to whatever I am saying. There will be coincidence between these two. Therefore, you will be able to follow easily. So whenever you are watching my video, you have to have the notes side by side, refer the notes and to the words which I am saying, then you will have a coincidence and then you will be able to remember very easily. Therefore, this can be written as change in energy delta E is equal to EH by 4 pi m B into m of L to m of S. But delta E is the change in energy, H is Planck's constant, E is charge of the electron, m is mass of the electron and B is strength of the magnetic field. We can write this in terms of frequency also. I told you, you know E is equal to h nu or it can be written as C by lambda. Nu is the terms of frequency. C is the velocity of light. Lambda is nothing but the wavelength that is due to change in transition. I told you there are 2 types of transitions. So this is the ground state, this is the excited state. If it is moving from ground state to excited state, absorption. It is moving from excited state to ground state means it is emission. So this is known as transition. That is known as transition. Therefore, when an electron is moving from ground state to excited state or is moving from excited state to ground state, there will be change in frequency. Definitely due to transition there will be change in frequency. That change in frequency is nothing but delta nu is equal to delta E by H. Frequency can be written in terms of E. I have told you E is equal to H nu. Therefore delta E is equal to H times delta nu. Therefore delta nu is equal to delta E by H. So you get the expression E is equal to H nu. In change of energy and frequency, you can write delta is equal to H into delta nu. Therefore, change in frequency delta nu is equal to delta E by H. Therefore, this expression according to change in frequency can be written as delta nu is equal to E B by 4 pi m. This H and H will get cancelled times m of L into 2 m of S. Magnetic orbital quantum number m of L and spin quantum number m of S. That is what I told you, J equal to L plus Z. Total orbital quantum number is equal to sum of spins plus sum of orbital quantum number. Therefore, the quantity, this quantity m of L plus 2 m of S, this quantity is known as strong. This is known as strong field quantum number. Strong field quantum number. The quantity m of L plus 2m of S is called strong quantum number, and m of L plus 2m of S will always be a integer because S value is plus half and minus 1. So the strong field quantum number will always be an integer. And finally, in a strong magnetic field, a given spectral line is split into 3 components. So, according to Paschen and Back, they have come to a conclusion that when a strong magnetic field is applied on a spectral line, it split up into 3 lines, 3 spectral lines, and this is approximately equal to anomalous Zeeman effect. So, they have come to a conclusion that Paschen-Back results are very much agreement with anomalous Zeeman effect. So, Paschen-Back also proved that there is anomalous Zeeman effect. Okay, thank you. In the next class, we will see about Stark effect.